Hey there, everyone. Welcome to another deep dive. Today we're tackling software design patterns in Java.
A big topic for sure.
Yeah, it really is. If you're listening to this, I bet you're working on some kind of project, or maybe getting ready for an interview,
That's probably right.
or maybe you just love learning about code. Whatever brought you here, get ready to unlock some of the secrets of really great programmers.
Yeah, we're going to be talking about elegant solutions to really common problems you find in coding.
You know, I always think of design patterns like having blueprints from an architect.
That's a great analogy. They're like pre-made solutions for problems that pop up again and again in software.
So using these patterns can really save you a lot of time.
Absolutely. You don't have to reinvent the wheel every time you run into a problem.
So then where do all these patterns come from?
Well, way back in 1994, a group of experienced developers, the Gang of Four, they're often called, published a book.
The Gang of Four, huh? Sounds kind of mysterious.
Well, their books become like a Bible for software developers.
I see, so it's packed with all these time-tested patterns.
Exactly. And you know what's amazing?
Right.
A lot of those patterns are still super relevant today, even in a modern language like Java.
So this book's like a time capsule of coding wisdom. Where should we start with all these patterns?
Okay, let's say you're building a really complex user interface, like for an online shop.
Okay, I'm with you.
Now, how do you make absolutely sure that when a user changes something in their shopping cart, like adds an item, the user interface updates instantly, like without any glitches or delays?
Right, you don't want the customer adding things to their cart and not seeing it reflected on the screen. That'd be super confusing.
Exactly. That's a recipe for disaster.
So how do we avoid that?
That's where the observer pattern swoops in to save the day. It's like subscribing to a notification service.
Hey, notification service.
Yeah, think of it this way. The shopping cart is like a publisher. And then any part of the user interface that needs to know when the cart changes, like, you know, that mini cart display, the checkout button, those things,
Right.
they all subscribe to the cart's updates. So it's like they're all saying, hey, keep me posted.
I see. So whenever something in the cart changes, all those parts of the interface get a notification.
Exactly. And they can update themselves accordingly. The cool thing is that the shopping cart doesn't need to know exactly how each part of the interface updates itself.
Just that they want to know when something changes.
Right. Like, imagine you're sending out invitations to a party. You just need to know who wants to be invited. You don't need to know how each person is going to get to the party.
I like that analogy.
Yeah.
So how does this work in Java specifically?
Well, Java actually has built-in support for this pattern.
Does it?
Yeah.
Yep.
With the observable interface and the observer interface.
Okay, so this observer pattern's sounding pretty useful. Any real-world examples of where it's used?
Oh, yeah. Tons. You see it all the time in Java FX applications.
Java.
Yeah, if you're building a graphical user interface with Java FX, the observer pattern is essential.
Okay, so it's like the magic glue that keeps everything in sync in those applications.
Precisely. So much cleaner than constantly checking for changes manually.
Okay, what other patterns should we know about?
Well, let's say you have a bunch of data, like a shopping list or a music playlist or even lines of code in your program.
Okay.
And you need a way to go through each item in that data, one by one, without messing up the original order.
Yeah, that sounds like something that would come up all the time.
It totally does. That's where the Iterator pattern comes in. It's like having a little pointer that moves through your data, showing you each item without changing anything.
So instead of having to write those loop things every time you want to go through a bunch of data, you use this iterator.
Exactly. And Java has built-in support for this too. It uses these things called the iterable and iterator interfaces.
Interfaces, right.
Yeah.
I remember those from my Java class.
Yeah. So if a collection of data implements the iterable interface, it means you can easily use an iterator to loop through all the items in it.
So it's like it's giving you permission to use the iterator.
Pretty much. And you can even use that fancy for each loop in Java, which makes your code super readable.
Oh yeah, I like those. Very clean. Can we see a real-world example of this iterator thing?
Sure. Imagine you're working with a stack.
A stack. What's that?
It's a data structure, kind of like a stack of plates. You can only add or remove items from the top.
I see. So how does the iterator work with that?
Well, let's say you want to look at every item in the stack without changing the order. You can use an iterator for that.
Okay, so how would we actually code that up?
There's a good example in the source material. You basically create an inner class within your stack class. This inner class, it's the one that implements the iterator interface.
Okay, starting to get a little complex now.
This inner class has two main methods, has next and next.
Next. Okay, so those are the ones that do the work of moving through the data.
As next checks if there's another item in the stack to look at, and next actually gives you that item.
What else is in this design pattern toolbox?
Let's zoom out a bit. Instead of looking at individual objects, let's think about how we structure entire applications.
Okay, that's a bigger picture.
Exactly. This is where the Model View Controller pattern comes in, or MVC for short. You've probably heard of it.
MVC, yeah, rings a bell.
It's super popular in web development.
Oh, yeah, that's right. Can you remind me how it works again?
Think of it like this. You're building a house. You have your blueprints. Those are the model.
Okay, the model's the plan.
Then you have the construction workers. They're the controller. And finally, you have the actual house, the one people live in.
Okay, that's the view. I get it.
So how does this apply to software?
Yeah, that's the part I always get tripped up on.
Well, the model represents the data and the logic of your application. It's like the brains of the operation.
The brains, okay.
The view is what the users see and interact with the user interface.
Makes sense.
And the controller is like the middleman.
The middleman.
Yeah, it takes user input from the view, updates the model, and then tells the view to display the changes.
So it's like the communication hub.
Exactly. And
Yeah.
this separation of concerns is super important. It makes your applications way more organized, easier to maintain, and much more flexible.
Yeah, I'm seeing how that would be super helpful.
And guess what? Some of the most popular Java frameworks out there, like Spring MVC, are built on this pattern.
Wow, so this MVC thing is a pretty big deal in the Java world.
It is. So many of the apps and websites we use every day are built using this pattern.
It's like the foundation of the internet. Okay, so we've talked about MVC for structuring applications. What about handling actions within those applications?
Great question. Let's say you have a complex operation that you might need to undo or redo. Like, think of those undo and redo buttons in software.
Yeah, those are lifesavers.
That's often the command pattern in action.
So the command pattern's all about managing action.
Exactly. It lets you package up a request or an action as an object.
Okay, and why is that useful?
Well, it means you can do all sorts of cool things with those actions. You can store them, execute them, even reverse them.
Reverse them, like undo.
You got it. The command pattern makes implementing features like undo and redo much easier.
So instead of directly calling a function to, say, deposit money into a bank account, I'd create a deposit command object.
You're getting it. That's how it would work.
And then this command object would hold all the info needed for that deposit.
Right. Like the account number and the amount of money.
This is pretty mind-blowing. I never realized how much thought goes into designing good software.
Oh, there's a lot to it. And we've only just scratched the surface.
Okay, so we've covered a lot of ground with these design patterns. It's amazing how much they can improve our code. But I'm a visual learner. Can we see some of these patterns in action? You know, with some real-world examples.
Absolutely. The source material actually has some cool examples that bring these patterns to life, like the observer pattern, for instance.
Yeah, that one really clicked for me.
Remember how we talked about using it to keep a user interface in sync with the data?
Yeah, like in that online shopping cart example.
Exactly. Well, the source material shows how you can actually do that with JavaFX. Imagine you're building that shopping cart feature with JavaFX.
Like that.
You can use the observer pattern to make sure that what the user sees is always up to date with what's actually in their cart.
Okay, so we've got the actual shopping cart data. That would be like a list of items the users added, right?
Right. You'd probably have a class called shopping cart that holds all the information about the items in the cart.
The product name, price, quantity, all that.
Exactly. And that shopping cart class would be the subject in our observer pattern.
Okay.
And then you'd have the part of the user interface that actually displays the cart. That would be our observer.
So like the little cart icon that shows how many items are in there, and then the page where you actually see the list of items.
Exactly. You might have a custom component called shopping cart view that displays the cart's contents to the user.
Makes sense.
So whenever the data in the shopping cart changes,
Like when the user adds or removes an item.
right, the shopping cart would notify the shopping cart view saying, hey, something's changed, update yourself.
So it's like an automatic refresh.
Precisely. The shopping cart view then takes care of updating itself based on the latest data.
I see. So much cleaner than constantly checking for changes manually, right?
It is, and it makes the code so much more modular and easier to maintain.
Modular, right? Because you can change the way the cart is displayed without messing with the underlying data.
Exactly. This pattern is used all the time in GUI development to create those really responsive and dynamic user interfaces.
Powerful stuff. Okay, what about the MVC pattern? Remember, that one was for structuring entire applications.
Yeah. The source material actually uses a shopping cart application to demonstrate MVC. Remember the model, the view, and the controller.
Like the blueprints, the construction workers, and the house.
Exactly. So in this example, the shopping cart class would be the model, holding all the data about the cart.
Okay, that's familiar.
And then you'd have the shopping cart UI, which would be the view.
The part the user sees and interacts with.
Right. And then there's the shopping cart controller that acts as the intermediary between the two.
Okay, the controller is the one that makes sure everything's talking to each other.
Exactly. It handles things like user input, updates the model, and then tells the view to refresh itself.
So when the user clicks Add to Cart, the controller receives that click, tells the shopping cart to add the item.
And then tells the shopping cart UI to update itself.
I see, so everything stays perfectly in sync.
Precisely. It's all about separating concerns and making the code easier to understand and maintain.
Yeah, MVC is starting to make a lot more sense now.
Great. Now, how about we take a look at the command pattern in action?
Yeah, I remember you were talking about how it's used to manage bank transactions.
Right. The source material shows how you'd actually implement that in code. Remember those deposit command and withdraw command objects?
Yeah, like little packages of instructions for the bank account.
Exactly. Each command knows how to perform its specific action.
So the deposit command knows which account to deposit into and how much money to deposit.
Right. And then you have this other component called the invoker.
The invoker.
Yeah, it's the one that actually tells the commands to execute. In the example from the source material, they use a class called Transaction Manager as the invoker.
So the transaction manager is like the conductor of the orchestra.
Perfect analogy. You give the Transaction Manager a deposit command, and it says, okay, deposit command, do your thing.
And the deposit happens.
Exactly. And you can imagine how easy it would be to add new commands, like a transfer command.
Right, you wouldn't have to mess with the transaction manager or the bank account classes themselves.
Precisely. This separation makes the code super flexible.
Powerful stuff. Okay, what about that Memento pattern for undoing actions? How does that work in the real world?
Well, the source material uses the same bank account example to show how Memento can be used to undo transactions.
Okay, so if I accidentally withdraw too much money, I can use Memento to go back to my previous balance.
Exactly. Before you make a change to the bank account, like a deposit or withdrawal,
You create a Memento object that captures the account's current state.
you got it. It's like taking a snapshot of the account at that moment in time.
And then if you need to undo the transaction, you use that snapshot to restore the account.
Precisely. The source material even mentions using a stack to manage these Memento objects.
A stack.
Yeah, so you can undo multiple transactions in reverse order, like hitting the undo button multiple times.
That's a really clever way to handle that.
It is. And the Memento pattern isn't just for bank accounts. You can use it anytime you need to capture and restore an object's state, like in a video game or a design program, or even something more complex like a financial system.
This is a safety net for your objects.
Exactly. Okay, let's shift gears again and look at the strategy pattern.
Oh yeah, the one for choosing different algorithms.
Right. Remember the navigation app example with different routing algorithms for driving, walking, and cycling?
Yeah, I like that one.
Well, the source material uses a student grading system as an example. Imagine you need to calculate students' average grades.
Okay, I can see where this is going. There are different ways to calculate averages, right?
Exactly. You might have the arithmetic mean, the weighted average, maybe even some custom grading scales.
And each of those would be a separate strategy.
Precisely. So you have a student object that needs to calculate its average grade. Instead of putting all that calculation logic directly into the student class, you use the strategy pattern.
So the student object would have a reference to a grading strategy object, which could be any one of those calculation methods.
You got it. The student object doesn't need to know the details of how the average is calculated. It just tells the grading strategy object to do its thing.
That's pretty slick. Keeps the student class nice and clean.
Exactly. And it makes it really easy to add new grading strategies in the future.
Right, you just create a new strategy class that implements the grading strategy interface.
Precisely. And this pattern also promotes code reuse. You could use those same grading strategies across different parts of the application or even in different applications entirely.
Nice. So much flexibility.
It is. Okay, ready to tackle the factory patterns again.
Bring it on. Those were the ones for creating objects in a more structured way, right?
Right. Let's go back to that citation formatting example.
The one with different citation style.
Exactly. Well, the source material explains how you can use the factory patterns to handle not just the citation style, but also different output formats.
Output formats, like what the citation looks like when it's printed or displayed.
Exactly. You might want to format the citation as plain text, HTML, or even something like RTF.
Ah, so now we have two things to worry about. The citation style and the output format.
Right. That's where the different types of factory patterns come in.
Okay, remind me again, what are those types?
The two most common ones are simple factory and factory method.
And how are they different?
Well, with simple factory, you have one factory class that handles creating all the different types of objects.
So we'd have a citation factory that has methods for creating IE citations, APA citations, and so on.
Exactly. That works well for simple scenarios, but it can get messy if you have a lot of variations to deal with, like those different output formats.
And that's where factory method comes in.
You got it. With factory method, you define an interface for creating objects, but you let subclasses decide which class to actually instantiate.
Instantiate, right. That's the fancy word for creating an object.
Exactly. So instead of having one big citation factory class, you'd have an interface called citation style factory.
Okay.
And then you have concrete factory classes like iacetation style factory and a pacitation style factory that implement that interface.
So each concrete factory would know how to create citations in its specific style.
Precisely. And you could even have separate factories for the output formats, like HTML citation factory and plain text citation factory.
Wow, that's a lot of factories.
It is, but this factory method approach makes your code much more flexible and extensible.
Extensible.
Yeah, it means it's easy to add new features or variations later on without having to change a lot of existing code.
I can see how that would be super helpful, especially when working on a large project.
Absolutely. These factory patterns really give you a lot of control over how objects are created, which is super important for writing maintainable code.
This is really eye-opening. Okay, you mentioned there was one more factory pattern.
I did. It's the big one, the abstract factory pattern.
Okay, I'm ready. Bring it on.
It is. It's like the boss level of factory patterns.
Okay, I'm ready for the challenge. What makes this abstract factory so special?
Imagine you're building a graphical user interface toolkit that needs to work on different operating systems.
Okay, like Windows, Mac OS, and Linux.
Exactly. And you need your toolkit to provide things like buttons, text fields, scroll bars.
Right, all the usual widgets.
But those widgets need to look and feel native on each operating system.
Because a button on Windows looks different from a button on a Mac.
Right. And you wouldn't want to write a bunch of if statements all over your code to figure out which type of button to create.
Yeah, that would get messy fast. So how does the abstract factory help with this?
You'd create an abstract factory. Let's call it GUI factory.
Okay.
This factory would have methods for creating all the different widgets, create button, create text field, and so on.
But it wouldn't actually create the real widgets itself.
Exactly. It's more like a template.
Okay, so it's like the blueprint.
Right. And then you'd have concrete factory classes for each operating system.
Like Windows GUI factory, Mac GUI factory, and Linux GUI factory.
You got it. And each of those concrete factories would implement the GUI factory interface.
But they would create widgets that are specific to their operating system.
Exactly. The Windows GUI factory would create Windows-looking buttons. The Mac's UI factory would create Mac-looking buttons.
I see. And so the application would only ever talk to the abstract GUI factory.
Right. It doesn't need to know about the concrete factory classes at all.
So the code stays nice and clean and platform independent.
Precisely. The abstract factory pattern lets you create these families of related objects, like our GUI widgets, without tying your code to the specific details of each operating system.
That's really powerful. So we've covered all the main types of factory patterns now. Simple factory, factory method, and abstract factory. What else is there to know about design patterns?
Well, the real fun starts when you combine these patterns.
They bind them, like Voltron.
Exactly. You can mix and match these patterns to create really sophisticated solutions. Remember the Iterator pattern?
The one for moving through collections of data.
Right. Well, what if you combined that with the composite pattern, which is used to represent tree-like structures?
A tree-like structure, what do you mean?
like a file system on your computer. You have folders within folders within folders.
Right, like a hierarchy.
Exactly. So you could use the composite pattern to represent that hierarchical structure, and then use the iterator pattern to go through all the files and folders in that structure, no matter how deeply nested they are.
Ah, so I wouldn't need to write those complicated recursive functions to traverse the tree.
Exactly. You could
Yeah.
just use an iterator to walk through the entire structure.
That's really elegant. I'm
Yeah.
starting to see the possibilities here. Combining these design patterns is like having a whole set of Lego blocks that you can use to build amazing things.
That's a great way to put it. And you know, we've really only scratched the surface of design patterns. There's so much more to explore, and I encourage you to keep learning and experimenting.
I definitely will. This deep dive has been so eye-opening. I'm already thinking about how I can apply these patterns in my own projects.
That's what it's all about. And remember, the source material has a lot of great resources and examples to help you along the way.
I'll definitely be checking those out. A huge thank you to you for being our expert today. This has been a fascinating journey through the world of software design patterns.
It's been my pleasure.
And to everyone listening, thanks for joining us on this deep dive. We'll see you next time.